All right, we're on page 3 now. The direction of a moving car changes and its speed remains constant. Which quantity must remain the same? The direction changes. We haven't done some of these, so momentum is not the answer because that's mass times velocity, and if the direction changes, the velocity is changing. The displacement, that definitely is dependent on velocity, so that's not good, and velocity. So distance covered is correct. So even if you're going in a circle, you're changing direction all the time, your distance is still the path that you follow. So if the speed remains constant, the distance covered will stay the same. Let's see, question 23. In the diagram below, 10 kilogram block is at rest. If it's at rest, that means F net is 0 because A is 0. It's static equilibrium. That means if you look at the forces, you have, well, let's do it this way. You have FG parallel down the incline, FG perpendicular, and you have Fn. There has to be a force here that balances this one. These two are in equilibrium and these two are in equilibrium. So as the angle of the incline is increased to 30 degrees, the mass of the block doesn't even care about all this stuff that I just said. None of this matters. The mass stays the same. What a waste of time. All right, two carts are pushed apart by an expanding spring as shown in the diagram below. If the average force on the 1 kilogram cart is 1 Newton, what is the average force? This is Newton's third law. Every action equal and opposite reaction. If it's 1 Newton on this one, it's 1 Newton on this one. The result will be different on the two carts because of the different masses, but the forces are the same. Newton's third law. Which object has the greatest inertia? Or inertia is measured by mass. So which one of these has the greatest mass? I think it's a seated high school. It does not matter that V is 0. We'll talk later in the year about momentum, which is M times V, but inertia is just mass. A baseball dropped from the roof of a tall building takes 3.1 seconds to hit the ground. How tall is the building? I'm going to work over here. D equals V initial T plus 1/2 AT squared. You could have picked another formula and figured out you're going to be wrong with that one because you're trying to figure out D. The only other equation with D in it is the VF squared equation, but we do not know what VF is. VF is not 0. When it reaches the ground, it's traveling at some speed or some velocity. It's not 0. So we're solving for D. It's from rest, I believe. It's dropped, so I'm assuming it's at rest. 1/2 negative 9.8 T squared is 3.1. Again, you guys are going to plug in units when you do part 2 questions. Half of this is about 5. This squared is about 10. I'm going to say the answer is about 50. Looks like 47 is a good one. Why do they have positive 47? They want to know how tall the building is. This answer would have been negative 50 meters or negative 47. The negative just means the displacement. It's a vector. It means down or finished below where it started. What is the acceleration due to gravity at a location where a 15 kilogram mass weighs 45? Fg equals mg. This is the acceleration due to gravity. If you know the weight is 45 newtons, the mass is 15 kilograms, you can find what g at this location, whatever you want to call that g. G is equal to 3 newtons per kilogram, or meters per second squared. There's that. Next question. The diagram below shows a sled and a rider sliding down a snow-covered hill that makes an angle of 30 degrees with the horizontal. So we have our picture. Which vector best represents the direction of the normal force? That's easy. There's normal force. It's got to be perpendicular. So which of these is showing that? That's not showing it. That's not showing it. This would be Fg perpendicular, which the value is correct, but, or the length of that shows you the value, but the direction is the opposite. That there's, again, this is kind of a funky picture, but I think the idea is there's your slope. As a car is driven south in a straight line, with decreasing speed, so V is in this direction, but it's getting smaller and smaller. So smaller, smaller. I don't know if that helps. The acceleration of the car must be, if you're basically slowing down, your acceleration is in the opposite direction. So the acceleration has to be north. At the closest known approach, it would take light approximately 187 seconds to travel from Mars to Earth. How far would it be to Mars at this time? So V equals D over T is what we're using here. You know that it takes 187 seconds. And they want to know what is the distance to Mars. The question is how fast does light travel? If you look on your reference table, it's 3 times 10 to the 8th meters per second. Again, you have to do the math, and I'm not doing so well at this. I don't know what that is. Maybe 5.6 times 10 to the 10th. That's one of the answers. So we'll use that. Double check the work, though. Again, this comes from the front of your reference table where all the constants are. We haven't learned it. We will learn it more when we get to the second half of the year, but it's still in there, so apparently be ready to use it. Which of the following is equivalent to a Newton? A Newton is the unit for force. So Fnet is MA. If you want to know what a Newton is, it's a kilogram, which is the unit for mass, times a meter per second squared, which I believe is answer number 2.